There's a tool that has shipped inside every version of Windows for over 2 decades. Most users have never heard its name. Most IT professionals have used it hundreds of times. And ransomware operators, nation-state attackers, and cybercriminal groups have abused it so reliably, so effectively, and so extensively that it appears in the attack chains of some of the most damaging cyber incidents in the past decade, not as something the attacker brought with them, but as something they found already waiting on the machine they compromised. It is called WMIC, the Windows Management Instrumentation Command-line tool. And as of August 2026, in a decision announced in Microsoft's release notes published in the past several hours, it is being removed from Windows 11 entirely. Not disabled, not hidden, removed permanently from every new installation and every existing machine receiving the August update. Because after years of ransomware operators using illegitimate, Microsoft signed Windows executable to move through corporate networks, steal credentials, execute payloads, and disable security software, all without triggering the alerts that actual malware would trigger. Microsoft has made the decision that the tool's security cost has outweighed its administrative utility. This is the story of what WMIC is, how attackers have been using it against you, what its removal actually changes about your machine's security posture, what breaks when it disappears, and what you need to know to stay on top of both the security improvement and the operational implications of one of the most significant changes to Windows' default toolset in years. Let's start with the question that most users will have immediately. What is WMIC? And why has something with this much security significance been sitting quietly inside Windows for over 20 years without most people knowing it existed? WMIC, pronounced either as individual letters or sometimes as WMIC in IT circles, stands for Windows Management Instrumentation Command-line. It is a command-line interface to the Windows Management Instrumentation infrastructure, a powerful, deeply integrated system that allows software to query and control virtually every aspect of a Windows system's configuration, hardware, software, and runtime state. Through WMI, a program or an attacker can query the list of running processes and their properties. They can enumerate installed software. They can check hardware configurations, read BIOS information, query network adapter settings, and examine storage configurations. They can start and stop services. They can execute arbitrary commands with the privileges of the calling process. They can set up persistent event subscriptions, essentially installing backdoors that execute code automatically in response to system events that survive reboots and persist across user logins. They can interact with the Windows registry. They can query and modify Active Directory information in domain environments. And they can do all of this through a command-line tool that is signed by Microsoft, trusted by the operating system as a legitimate administrative component, and therefore does not trigger the alerts that actual malware executables would trigger when they perform the same operations. WMIC is considered a lull bin, or living off the land binary. That means it is a real Microsoft-signed Windows executable that bad actors can abuse during an attack instead of deploying their own tools. Threat actors have abused WMIC. The living off the land concept is one of the most important ideas in modern cybersecurity, and understanding it is central to understanding why WMIC's removal matters. Traditional malware detection, the kind that antivirus software has performed for decades, works by identifying malicious software based on its characteristics. A virus has a specific signature. Ransomware has behavioral patterns. Unknown executables are flagged as suspicious. But what happens when the attacker does not bring their own tools? What happens when instead of deploying a custom malicious executable that might be detected, the attacker uses the legitimate administrative tools already present on the machine to accomplish the same goals? The antivirus cannot flag WMIC as malicious because WMIC is not malicious. It is a legitimate Microsoft component. The behavior the attacker is performing with WMIC querying processes, executing commands, enumerating the network looks identical to what a legitimate administrator would do with the same tool. The detection signal that would identify a custom malware tool performing these actions disappears when the same actions are performed through a trusted Windows binary. This is why living off the land attacks have become the preferred technique of sophisticated threat actors, particularly ransomware operators, who need to perform extensive reconnaissance, lateral movement, credential theft, and payload deployment across a network before detonating their encryption, all without triggering the defenses that are watching for malicious code. WMIC has been one of the most widely abused lull bins in the Windows ecosystem precisely because of its combination of power. It can do almost anything an attacker needs and trust. It is signed by Microsoft and present on every Windows machine. Let's look at specific documented cases of WMIC abuse, because the abstract description of ransomware abuses, WMIC, becomes far more concrete and far more alarming when you see the specific ways it has been incorporated into real-world attacks against real organizations. Ransomware operators have used WMIC to delete shadow copies, the Windows Volume shadow copy service snapshots that can be used to restore files to previous states immediately before deploying their encryption payload. The specific command is well documented in ransomware incident reports. Using WMIC to call the delete method on the Win32 shadow copy class, removing all shadow copies from the compromised machine ensures that victims cannot use the built-in Windows recovery mechanism to restore encrypted files without paying the ransom. This technique has appeared in the attack chains of Lockbit, Conti, Revil, Black Hat, and virtually every major ransomware family of the past 5 years. It works because WMIC is a trusted Microsoft tool performing a legitimate Windows operation. Deleting shadow copies is not inherently malicious, which is why defenders struggled for years to distinguish legitimate administrative shadow copy deletion from ransomware's pre-detonation preparation. WMIC has been used for lateral movement, spreading from one compromised machine across the network to others. The WMI infrastructure natively supports remote execution through the DCOM protocol, meaning an attacker who has compromised one machine and has network credentials can use WMIC to execute commands on other machines in the same network without needing to deploy additional tools on those remote machines. In domain environments, where service accounts or administrator credentials are shared across multiple systems, a common configuration in enterprise networks, WMIC-based lateral movement can propagate an attacker's presence from a single initial foothold to dozens or hundreds of machines within minutes, entirely through a trusted Microsoft-signed tool making normal WMI calls. WMIC has been used for reconnaissance, gathering information about a compromised environment to understand what is present, what security tools are running, what domain structure exists, and where valuable data is located. An attacker who has gained initial access to a single machine and wants to understand the broader environment can use WMIC queries to enumerate domain controllers, list all machines in the domain, identify which machines are running security software that might interfere with their operations, and map the network in ways that inform their subsequent attack decisions, all through commands that look indistinguishable from legitimate administrative activity. WMIC has been used to establish persistence, the mechanisms by which an attacker ensures their access survives reboots and discovery attempts. WMI event subscriptions, configured through WMIC or the underlying WMI interface, allow attackers to install code that executes automatically in response to system events, a user logging in, the system reaching a certain time, a specific process starting. WMI-based persistence is notoriously difficult to detect because it does not create the traditional persistence artifacts, registry run keys, scheduled tasks, startup folder entries, that security tools typically monitor. It lives in WMI's own database, executed by Windows' own service, triggered by Windows' own event infrastructure. Detecting it requires specifically monitoring WMI subscription activity, which many security tools did not do comprehensively until after WMIC-based persistence became widely documented. WMIC has been used to disable security software. Many endpoint protection products expose WMI interfaces for management purposes. An attacker who knows the appropriate WMI class and method for a specific security product can use WMIC to call that product's stop or disable method, potentially disabling real-time protection before deploying ransomware or other payloads. Where products have protected their WMI interfaces against unauthorized access, attackers have used alternative WMI methods to stop the underlying services that security software depends on, again through trusted Windows infrastructure that does not inherently appear malicious. The cumulative picture of these documented abuse cases explains why WMIC appears so consistently in post-incident analysis reports. WMIC was disabled last year, but it wasn't fully removed, and that changes with the August 2026 update. Windows 11 24.8.2, 25.8.2, and 26.8.2 will stop shipping with anything related to WMIC. Microsoft's decision to proceed from disabled to fully removed reflects an understanding that disabled is not sufficient. Disabled components can be re-enabled, and the existence of a disabled WMIC on the machine still provides attackers with a potential target if they can find a path to re-enabling it. Fully removed means the attack surface does not exist. Starting in August 2026, Windows 11, versions 24.h2 and 25.h2 no longer include the Windows Management Instrumentation Command-line utility. WMIC is already removed by default in new installations of Windows 11, versions 24.8.2 and 25.8.2, and is no longer available as a feature on demand. This language, no longer available as a feature on demand, is the specific technical detail that confirms the completeness of the removal. Feature on demand is the Windows mechanism for optional components that are not installed by default but can be added through settings or DISM. In previous configurations, where WMIC was disabled but not removed, An administrator could potentially re-enable it by reinstalling it as a feature on demand. With WMIC removed from the feature on demand catalog entirely, this re-enablement path no longer exists. The tool is gone from the ecosystem, not merely hidden. Now, let's talk about what this removal means in practice, both for security and for the users and administrators whose workflows have depended on WMIC, because both sides of this equation deserve honest assessment. From a security perspective, WMIC's removal is a genuinely positive development that addresses a documented, persistent, and extensively exploited attack surface. Every machine that no longer has WMIC present is a machine where the specific WMIC-based attack techniques used by ransomware operators, shadow copy deletion through WMIC shadow copy delete, remote execution through WMIC or Droit node, WMI-based persistent setup through WMIC TrueWort namespace simply cannot be executed in their traditional form. The attackers who have built these techniques into their playbooks will need to find alternative approaches. Some alternatives exist. PowerShell provides access to WMI through its own CMD-lets, for example, but each alternative has different detection characteristics, different privilege requirements, and different behavioral signatures that allow security tools to build more targeted detection logic than was possible when the same WMI capabilities were accessible through a single trusted binary. Microsoft later confirmed it would remove WMIC because PowerShell and other tools are already more than enough for those who relied on the legacy tool. This is Microsoft's position on the administrative continuity question, that legitimate administrative tasks previously performed through WMIC can be accomplished through PowerShell's WMI CMD ELETs, the newer CIM CMD ELETs that provide an updated interface to the same underlying infrastructure, and other modern Windows management tools that have been available and supported for years. For most administrative tasks, this is accurate. PowerShell provides equivalent or superior capability to WMIX for virtually every legitimate management use case, with better scripting integration, better output handling, and better compatibility with modern Windows management frameworks. However, the operational reality for specific environments and specific workflows is more nuanced. Scripts and automation systems that reference WMIC explicitly, scheduled tasks, batch files, monitoring scripts, deployment automation, security response playbooks, will produce errors after August 2026 if they have not been updated to use alternative commands. The presence of WMIC calls in production automation is not just an enterprise concern. Home users who have downloaded scripts for system management, performance monitoring, or customization over the years may have WMIC-dependent scripts in their environment that will stop working without modification. Let's now talk about the broader Elolbin problem that WMIC's removal addresses only partially, because WMIC is not the only living off the land binary that attackers abuse, and understanding the broader landscape of trusted Windows tools that malicious actors exploit helps frame both the significance of this specific removal and the limitations of what it accomplishes. The MITRE ATT-ANSI-K framework, the authoritative reference for cybersecurity attack techniques used by defenders and security researchers worldwide, documents dozens of Windows native tools that threat actors have used as lulbins in documented attacks. CertUtil, the certificate management utility, has been used to download malicious files from the internet because a Microsoft-signed certificate tool making an HTTPS connection does not trigger the same alerts as an unknown executable doing the same thing. Run DLL32, a tool for running code from DLL files, has been used to execute malicious payloads without needing to create a standalone executable. RegEsVyar32, another DLL-related utility, has been used similarly. MSHTA, the HTML application host, has been used to execute malicious HTA files. BitsAdmin, the background intelligent transfer service administrative tool, has been used to download additional malware using Windows' own download infrastructure. PSExec, technically a sysinternals tool rather than a default Windows binary, but widely present in enterprise environments, has been used extensively for lateral movement. In CertUtil, WSScript, CSScript, and a range of other utilities with legitimate purposes have all appeared in documented attack chains as the vehicles for malicious activity that leverages trusted code rather than deploying untrusted code. WMIC's removal does not eliminate this broader attack surface. It eliminates one particularly powerful and particularly well-documented member of it. The attack category living off the land predates WMIC's abuse and will continue after WMIC's removal through the remaining Elolbins in the Windows ecosystem. Security defenders who have been specifically monitoring for WMIC-based attack patterns will need to expand or redirect that monitoring toward the alternative paths that attackers will use now that WMIC is gone. The attackers themselves are adaptive. Their playbooks will be updated, their attack chains will be modified, and the tools they reach for will shift to whatever remains available on their target's machines. This is the ongoing arms race dynamic that defines modern Windows security, and it is the same dynamic we have discussed in the context of AI-powered vulnerability discovery and patching throughout this series. Microsoft removing WMIC is a meaningful defensive improvement. It is not a permanent resolution of the LOLBin problem, which requires ongoing monitoring, detection, and response capabilities, rather than a one-time removal of a specific tool. Now, let's talk about what you need to actually do, because this change affects both your security posture and potentially your operational environment, and the appropriate actions differ based on your situation. The first action is understanding whether you will receive the WMIC removal through the August 2026 update cycle. Windows 11, 24H2, 25H2, and 26H2 will stop shipping with anything related to WMIC. If you're running Windows 11 version 24H2 or 25H2, the current stable releases, the August 2026 update will remove WMIC from your installation. Verify your Windows version by opening Settings, then System, then About, and checking the Windows specifications for your version number. If you are on 24H2 or 25H2 and receive the August update, WMIC will be gone after the update installs and the system restarts. The second action is checking whether any scripts, automation tools, or scheduled tasks on your machine reference WMIC. Open PowerShell and search for WMIC references in common locations. Scheduled tasks, startup scripts, and any scripts and locations you use for automation. A simple PowerShell command can search text files in specified directories for the string WMIC, get child item, path C _ scripts, recurse, include tot.bat, cmd, ps1, select string, pattern, WMIC, modified to point to wherever your scripts live. Any files that reference WMIC need to be updated to use the PowerShell WMI equivalent commands before the August update removes the tool. The third action for users who find WMIC references in their scripts is understanding the PowerShell equivalents for the most common WMIC commands. The most frequently used WMIC commands and their PowerShell getWMIObject or getSimInstance equivalents follow consistent patterns. WMIC process list becomes getProcess or getSimInstance. Win32 process in PowerShell. WMIC CPU getName becomes getSimInstance, Win32 processor, with the name property selected. WMIC BIOS get serial number becomes getSimInstance, Win32 BIOS with the serial number property. WMIC product getName becomes getSimInstance, Win32's product with the name property. For the specific ransomware associated command WMIC shadow copy delete, the shadow copy deletion that ransomware uses before deploying encryption, the PowerShell equivalent involves getSimInstance Win32's shadow copy followed by the remove method, though this is an action that should only be performed deliberately by administrators who understand its consequences. The fourth action is specifically for IT administrators managing enterprise Windows environments. The WMIC removal represents an opportunity to audit all production automation, monitoring, deployment scripts, and security response playbooks for WMIC dependencies, and to update those dependencies to modern PowerShell equivalents before the August update forces the issue. A proactive update to PowerShell-based management commands is better than discovering script failures in production after the tool disappears. This audit should include not just scripts you maintain directly, but also third-party monitoring agents, security tools, and management software that may call WMIC internally. Vendors of these products should be contacted to confirm their August 2026 compatibility status. The fifth action is enabling and verifying that WMI activity monitoring is active in your security tooling, because WMIC's removal does not remove the underlying WMI infrastructure. It removes the command-line interface. Attackers who shift from WMIC to PowerShell's WMI CMD-lets or to direct COM-based WMI access are still performing WMI operations, still creating WMI event subscriptions for persistence, still using WMI for lateral movement through DCOM. Microsoft Defender for endpoint and third-party EDR solutions have specific WMI monitoring capabilities that detect suspicious WMI activity regardless of which tool initiated it. Verifying that these detection capabilities are enabled and their signatures are current is the appropriate security response to the shift in attacker tooling that WMIC's removal will drive. The sixth action is reviewing and hardening your Windows shadow copy configuration specifically, because the shadow copy deletion technique that ransomware uses through WMIC will require attackers to find an alternative method. PowerShell, VSS admin, or direct VSS API calls, and defenders need to ensure their monitoring covers these alternative paths. Configuring Windows shadow copy to run on an appropriate schedule for your recovery needs and setting up monitoring that alerts on unexpected shadow copy deletion, regardless of the tool used to delete them, closes the detection gap that WMIC-based deletion has historically exploited. The seventh action involves the broader Windows Defender security stack hardening that Microsoft has been rolling out alongside these tool-level changes. Microsoft's blog argued that Windows 11 already includes a complete antivirus stack through Microsoft Defender Antivirus, Smart Screen, Smart App Control, ransomware mitigation, and cloud-delivered protection. Microsoft's controlled folder access feature, found in Windows Security, then Virus and Threat Protection, then Ransomware Protection, provides specific protection against ransomware's file encryption behavior by preventing unauthorized applications from modifying files in protected folders. Enabling this feature and adding your important data folders to the protected locations list provides a layer of protection that operates independently of whether the attacker uses WMIC, PowerShell, or any other tool to deploy their ransomware payload. The eighth action is the broader security hygiene that makes living off the land attacks harder across the board, because the LLBin attack category exploits the trusted status of legitimate Windows tools, and the defenses against this category are different from the defenses against traditional malware. Principle of least privilege, ensuring that user accounts run with only the permissions they need for their actual work, rather than administrator privileges, limits the damage that WMIC or any other LLBin can do when abused, because many of the most damaging WMIC operations require elevated privileges, or application control policies, blocking the execution of scripts and command-line tools from user-writable locations, limit the contexts in which LLBins can be invoked, and network segmentation, preventing arbitrary lateral movement between machines, even for authenticated connections, limits how far WMIC-based or PowerShell-based lateral movement can spread once an attacker has an initial foothold. Let's close with the significance of what Microsoft has done here, because the WM's key removal represents something more than the elimination of a single command-line tool. It represents a willingness to accept operational friction to break legitimate workflows that administrators have relied on for 20 years, in the service of a security improvement that will measurably reduce the attack surface of every Windows 11 machine in the world. Microsoft has historically been cautious about removing components that might break existing workflows, prioritizing backward compatibility so highly that vulnerabilities and attack surfaces were sometimes preserved specifically because removing them might break something. The WMIC removal signals a shift in that calculus, a judgment that the security cost of maintaining a tool that ransomware operators have built into their standard playbooks now outweighs the compatibility cost of requiring administrators to update scripts to use modern alternatives. It's good news for everyone because WMIC has been abused to attack even regular consumers, and its removal should improve Windows 11 security, the company argues. This is the honest bottom line. Home users who have never run a WMIC command in their lives have still been attacked through WMIC because the ransomware that encrypted their family photos and work documents used WMIC to delete their shadow copies before detonating. After August 2026, that specific technique does not work on updated Windows 11 machines. The attacker will adapt, the arms race will continue, but this specific, well-worn path through your machine's defenses will be closed. Not by better detection, not by more aggressive scanning, but by the simple and irreversible act of removing the tool the attackers have been reaching for. 20 years, hundreds of thousands of documented attack incidents, one command-line tool, gone. And your machine, without you changing a single setting or making a single decision, is incrementally safer for it.